OpenID Connect Advanced Syntax for Claims. I'm a bit excited. This is actually the first time I'm presenting this outside of the working group. OpenID Connect Advanced Syntax for Claims is a specification that comes out of the eKYC Identity Assurance Working Group in the OpenID Foundation. So what is it? OpenID Connect Advanced Syntax for Claims, or ASK for short, defines extensions for OpenID Connect around requesting and receiving claims, obviously. So why do we need this? During the work in the eKYC working group, and probably also in some other places, it turned out that there's a real need for a finer grained control over how data is delivered so that relying parties can control what they get and how they get it. And there's two main reasons. First one, privacy. For example, if you want to do age verification, so you want to learn whether a user is, say, above 18 or above 21, you're not interested in the user's birth date. You just want to learn how old is the user. But with standard means, OpenID Connect only allows you to request the full birth date, which you might not need. And then for billing reasons. So if you have an ecosystem where relying parties are charged per individual claim, for example, or the same applies when they are charged for a group of claims, then clients need to be able to define what data they are interested in very precisely. And they don't want to pay for data that is useless to them. And these are two goals that Advanced Syntax for Claims helps to achieve. Also, if you look at OpenID Connect Core, by default, there are like two levels of, there are claims. So there are the normal claims like your first name. And then there are claims that have another level like address, which is a compound claim consisting of things like the zip code, street name, and the place. So there are two levels. But if you look at OpenID Connect for Identity Assurance, there are more than 5 levels, I think even 6 or 7 in some places, of nested claims. By the way, for anybody who doesn't know OpenID Connect for Identity Assurance, that is a standard that allows you to transfer not only claims, so it's an extension to OpenID Connect Core for transporting claims, but also information about whether the claims were verified. For example, if a bank has checked your data according to anti-money laundering law, and also to transport metadata about this verification. So for example, whether data was verified in person using a passport or an ID card, or whether it was a remote process and things like that. So that is OpenID Connect for Identity Assurance. Okay, so and these needs were identified during our work on OpenID Connect for Identity Assurance, and we tried to address them with OpenID Connect Advanced Syntax for Claims. ASK has no hard dependency on OpenID Connect for Identity Assurance, but as I said, the requirements were derived from that work, and there are some special provisions in OpenID Connect for in ASK to make it work with OpenID Connect for Identity Assurance. ASK consists of 2 independent extensions. The first one is called Selective Abort Omit, or SAO for short. And then there's Transformed Claims, or TC. We'll take a look at Selective Abort Omit first, and then take a look at Transformed Claims. So selective abort omit. And by the way, both extensions can be used independently from each other. So you can use selective abort omit without transformed claims and vice versa if you like. Selective abort omit is actually a relatively simple mechanism. As you can see in the example on the right here, for example, if you request the claim phone number, then you can say, if that claim is unavailable, please abort the transaction with an error message, standard OpenID Connect error. Unavailable can mean different things. It can mean that the phone number is not in the database of the IDP, but it can also mean that the user doesn't want to release this piece of information. In any case, if that number is not available, the transaction will abort. Then let's say you have a custom paid claim. And here we say, if this is unavailable, omit set. Omit set means that all claims that are marked with omit set will be omitted as well. And in this example, this example shows how this can be used, because there's a custom paid claim. And towards the bottom of the example, you can say that in the verified claims, the relying party is also requesting place of birth, which we assume here is also a paid claim. So the relying party is either interested in getting the custom paid claim and place of birth both, or none of them, so that relying party probably doesn't have to pay anything. And that makes sense, because maybe the relying party is operating in a trust framework where it needs to have both pieces of information. And if it doesn't get both of them, then it cannot do whatever it wants to do with the data. So it doesn't want to pay for that data. Therefore, the omit set mechanism allows the relying party to define a set of claims that must be delivered together. And so if unavailable is only one of two cases, the other case is if different. And you can see that here, nested inside this verified claims syntax, we don't need to go through all the details of that syntax. If you're not familiar with it, just assume that trust framework is an identifier for the trust framework within which this data was verified. So the relying party might have very specific requirements. Other than that, let's just say trust framework is a normal claim. So here you can see that in trust framework, the relying party says, I want to have this trust framework. So it uses the standard OpenID Connect feature of saying this has to be a specific value, DEAML. And then it says, using selective abort omit, if the value is different, then abort the transaction. So we have the two cases covered, if data is unavailable and if data is different from what the relying party defined. And then you can say either abort the transaction, omit this specific claim, which is the default in OpenID Connect, omit a set of claims, or you can also say omit the verified claims. You can see that in the next example here, and if unavailable, omit verified claims. And that is a mechanism that, as the name says, leads to an omission of all the verified claims in the response. Okay, so that is selective abort omit. Let me just check whether there are any questions so far. Doesn't seem like it. Now let's go to the, I think, more interesting part, and that is transformed claims. Transformed claims covers a number of use cases. And the most prominent one is age verification. Depending on your jurisdiction and other factors, you might be interested in learning whether a user is above 16, users above 18, above 21, or under 99, or whatever. So it really depends on your use case. And as you can see, of course, you could define a OpenID Connect claim saying age is 16 or above, for example. Sure, but then you also need to define many other claims for 18, 19, 20, 21, and so on. At the same time, you cannot express this using the standard OpenID Connect syntax with value or values. That doesn't work for the age. So there's something missing there. But transformed claims also covers other use cases. For example, if you want to say an email has to end with @company.com, or a zip code has to be a specific value. So as I said, address is a compound claim in OpenID Connect core. So it consists of a JSON object with one of the properties being the zip code. But you cannot match on that in standard OpenID Connect. In transformed claims, you can also say things like the country in the address must not be empty. Or you can say, for example, if you have nationalities, which can be an array of values, you can say that one of the nationalities must be that specific nationality. And then there's another use case, and that is data minimization. For example, if you're only interested in the country of the address or the zip code of the address, but not the address itself, or just the age, but not the birth date. And all of these cases are covered in transformed claims. So how does it work? The basic idea is that you can transform any of the existing claims in OpenID Connect, eKYC, or custom claims, whatever. You can take a claim, in this picture on the left as the original claim, and then apply transformation functions. For example, if you have the birth date, you can apply the function years ago, which calculates how many years ago that birth date was, which creates a new claim, the transformed claim 1 in this picture, for example, 18. And then you can apply another function, and that function would, for example, be, is this greater or equal to 21? And then you get another transformed claim, so you have transformed that claim twice. And the result of that transformation is just a Boolean value, yes or no, true or false. And the functions that you can apply to a claim have to be selected very carefully. There must not be any side effects, for example, on other claims. There can only be static arguments, except, of course, for the input value from the transformed claims, or the original claim, so the claim where it comes from. And there must be only one base claim or input to any function, and no external data is allowed in the calculation of the function, with the exception, for example, of the current date. So essentially global data. And if you have these properties for the functions, then you can implement this with, let's say, a complexity that is okay for the number of use cases that are covered with this specification. Also, because we're creating this nice chain starting from the original claim, you can have, or you can retain some of the properties of the original claim, meaning that if the original claim is unavailable, so will be the transformed claim. So specific properties translate from the original claim to the transformed claim. In any case, the transformed claim can then be used essentially like a normal claim. So you can check against it using the value or values features in standard OpenID Connect. You can use selective abort omit, so you can say if the value is different, then abort. And of course, you can just query it from the IDP. So the IDP would return true in this example. Okay, let's look at a concrete example. Here you can see a claims parameter. And within the claims parameter, there's a new key called transformed claims. And within this key, you define the transformed claims, or the relying party defines the transformed claims that it wants to request from the authorization server. Here we define a claim called above 18. Should probably be better called age 18 or above. And then we say the base claim. So what this is based on is the standard OpenID Connect claim birth date. And then we apply two functions. The first one is years ago, just as in an example on the slide before. And the second function is greater or equal to 18. So this just checks whether the user is 18 or above. And then this claim is defined and can be used almost like any other claim. You see that in the lower part of the left box in the ID token, can also be used in the user info endpoint, of course. But there's a prefix, the colon, to say that this is a transformed claim, so that there can be no name clashes. So here we just use above 18 and requested using the null value, which in OpenID Connect means to just return the value of that claim. And in the response, the OP will say above 18 is true. So they'll also use the colon prefix to say this is a transformed claim, the transformed claim that you defined, and the value of that is true. Okay, so this is a simple example for age verification. What else can you do? Well, you can do a lot. Although you don't need many functions to do that. A couple of the functions that are defined within the specifications are the ones you see here. For example, years ago, we have seen that in the example, greater than, less than, can also have greater than, equal, less than, or equal. There are rules defined on how to handle arrays of values. For example, you can say that any value within the array must be true, and then also the result of the any function is true, similar for all and none. You can do comparisons. Of course, you can also do comparisons using the value mechanism in OpenID Connect, but sometimes you need a function that compares something. You can use a get function to get a key within a JSON object. For example, get the zip code from the address. And of course, so to say, as a catch-all, and because I like regular expressions, there's also a match function that can apply a regular expression to a string. This you can use, for example, to match the domain within an email address. Here's another example. The keyword is email address. So here a transformed claim called company email is defined. And it says, based on the email claim, apply the function match for a regular expression and check whether that email address matches at company.com. And if that's the case, then a true is returned, otherwise false is returned. And then there's another transformed claim called nationality USA, which looks into the nationalities claim and looks whether there's a one of the nationalities matches USA, and then the any function, so if any of the nationalities matches USA, then it returns true. And again, at the bottom of the example, you can see how this is used in the ID token. For example, for the company email, it says that if the value is true, then return the value. Otherwise, if the value is not true, so if it's different, then abort the transaction. So the company email must be at company.com. And within the verified claims, nationality USA checks whether one of the nationalities is in fact USA. and if not, if the value is different, then abort the transaction. Now you might be thinking, if I just want to do age verification, this is a lot to implement with all the functions and the definitions and finding out which functions to apply and what the base claims are, all the error handling and so on. And yes, if you want to implement the full power of transformed claims, that's a bit of work. We'll get to that in a moment because somebody has done that work already. But if you just say, I want to do age verification and nothing else, or I want to match email addresses, but nothing else, then you're covered. And this is where the magic happens. You can simplify common use cases. OPs can say, I want to just support a limited subset of functions. So for example, for age verification, they can say, I'm just supporting years ago and greater than or equal. That's sufficient for age verification. But the OP can also say, I support predefined transformed claims. So instead of letting the relying party define the transformed claim, the OP can say, I have a predefined transformed claim for you. If you take a look at the example, transformed claims predefined is just what we saw before as transformed claims. So same contents, just this time it's in the OP metadata. And you can see it defines a claim above 18, just as in the examples before. So here the OP defines the transformed claim. And then it can say, that brings us to the last point here on the slide, the OP can say, I'm supporting only predefined claims. And if the OP does all these three things, the OP essentially supports only this one predefined transformed claim. And a predefined transformed claim can be used by any relying party without repeating the definition. So the relying party can just say, : above 18. I'm using your predefined transformed claim called above 18. Please return the result of that. And of course, at this point, nobody's checking whether the OP actually implements the full feature set of transformed claims. So the OP can just say, okay, above 18 is this custom Java function that I have somewhere. Nobody cares how you get to the result of above 18, but what the result is clearly defined in the OP metadata. Anybody can look it up. So you have essentially a very clear definition for custom claims. And especially for cases like age verification, the OP can then just say, okay, I have above 16 defined and above 18 defined because I'm a German OP and only 16 and 18 are relevant here. And the US OP can say I have 18 and 21 defined because those two are relevant to me. But whatever it is, the relying party can take a look at the metadata, see what the predefined transformed claims are, and then just use them. And the OP doesn't have to, essentially doesn't have to implement anything except for a custom claim called : above 18. Okay, so minimal implementation overhead if you do only predefined transformed claims, but all the power to do a lot of things if you don't rely on predefined transformed claims and instead implement transformed claims. Couple of UX considerations. So obviously, if somebody uses or offers a predefined transformed claim, the OP, which has defined that predefined transformed claim, can of course show a meaningful consent prompt to the user. The OP can just ask, are you above 18? Or do you want to release that you are above 18? If a relying party comes and brings its own, transform claims, of course, the OP can try to see whether it understands what the relying party is doing. The patterns are relatively simple, and there's not much variation here. So the OP can say if there's birth date and then years ago and then greater than or equal, that translates into a consent prompt saying the ERP wants to know whether you are X years old or above. Easy. Of course, there could be transform claims that the OP doesn't understand. You can combine these functions in many ways. So there's always a safe fallback in that the OP can just ask the user to release the full claim. So for example, the relying party wants to know your birth date. Even if only the age is released at the end of the day, it's always less data than came in, or that is contained in the base claim. So if you just ask the user to release the full base claim, you're on the safe side. It's an over approximation. It's not precise, but it's safe. There are no side effects in this function, so you cannot just magically take another claim and put that data into the result. There are no expressions over multiple claims, and there are also no dynamic arguments, which is important for this property. Couple of compatibility considerations. If you use transformed claims, any OP that doesn't understand transformed claims should ignore that claim. Of course, also the usage of transformed claims should be ignored by OPs because that's how it's defined in OpenID Connect. But an RP can, of course, check first whether an OP actually supports transformed claims. Ecosystems can define more functions. So if you have special claims in your ecosystem, for example, if you have the IBAN of a bank account, you might want to define a custom function that, I don't know, maybe extracts the country from the IBAN, something like that. And transformed claims can be used with or without the selective abort omit feature. So I'm coming to the end of what I have to say about transformed claims, but there's already an implementation by OAuth lead, by Tucker to be more precise. Tucker, do you want to start a demo?
Okay, thanks. And this is Taka Kawasaki, co-founder and software engineer at OAuth Lead, which is a company providing an implementation of OAuth and OpenID Connect. And may I share my screen? Yeah. Thanks. Do you see my presentation titled Transformed Claims demo? So in this demo, I'll edit first the file title named claims.json, whose content will be used as the value of the claims request parameter of an authorization request. Then I'll type make. This make will build a URL that represents an authorization request and launch a web browser with the URL. Then the web browser will show an authorization page where we will input ID and a password and press authorize button to authorize the authorization request that includes transform claims requests. Then the web browser will be redirected to the redirection endpoint. The page displayed at the redirection endpoint contains JavaScript, which decodes the response of the authorization request. And the response will include an ID token, and the payload part of the ID token will be decoded and displayed in the page. And then we repeat from 1 to 4 for other transformation functions. So yeah, let's start. And you can see that, can you see the web browser and the text editor and the terminal?
Yes, we see the schedule.
Yes.
and the editor.
So let's start the edit of the claims JSON and the transformed claims. And now, as the first step, let's define the simplest transformed claim named age. And we use this transformed claim references the birth date claim, and transformed functions that will be applied is just years ago transformation function, and this transformation function computes the years between the birth date input claim and the current date if no argument is given. And ID token is needed to request claims. In this example, we should request age transform claim. And in this first example, I want to add birth date claim to confirm the actual value of the birth date together with you, and save. Then type.
Taka, you have a typo.
There's a typo. Transform claims, line 2.
Transform. Oh, this does not work. Thanks. And make again.
There's still a typo. Taka-san, it's there it is.
Very
you got
sorry.
it.
Very sorry. No typo.
Still typo.
What?
Still typo. ID token birth date claims age birth date. Should work.
It looks good to me, Daniel.
Yeah, looks good.
Okay.
Sorry.
Thanks. Thank you very much. The next. Then an authorization page is displayed, and I'm sorry, this page, it does not display any information about the request transform claims. I did not have time to do that. And let's input the ID and the password, then press authorize button. Then this is an issued ID token, and we can confirm that this is the transformed claim we request, and the birth date is this 1956. So if you plus add 65 to 1956, you'll get the 2021, the current year. So the next, let's edit. Let's continue to edit this claims JSON. Now, so for age verified, for example, then let's add another transformation function, which takes an argument, and I removed the birth date claim from the ID token section to show that the transformed claim can work without the original claim. So I hope it will work. Let's make then math now otherwise. Then the age verified here true. So the skip. So this is the age verified claim, and let's try to try another other transformation functions. So for example, country, which refers address claim and yes, get and country. Let's request address to confirm the original value and country claim we defined. This is the address data. Then there are some elements in this address property, locality, region, and the country. The value of the country field is Germany, and we extracted this value nested under the address claim by using get function, and get function takes one argument, which is a key of a JSON object. In this use case, the JSON object is the here, and the country is used to extract this value. And okay, the next example is the nationality USA, and nationalities claim will be used as an input. Then the equal or USA, and because the value of the nationality claim is an array of country codes, the result of this transformation function will also be an array. And any is a special transformation function that receives an array as an input, then checks whether or any of the elements of the given array is true. The transformation function, this transformation function will generate an array whose elements are all Boolean values. So then, nationalities and nationality, nationality USA made. So the value of the nationalities claim is an array which includes USA and the DEU, and the transformed claim named nationality USA is now true because this array includes USA. And if you change any to all, then the result, the value of the nationality USA will become false, as you see. And so for example, as an interesting example is, for example, match a transformation function which accepts a regular expression. So USA this should match all the elements of the node end. So let's try. Now, true, the name of the transformed claim is wrong, but this result is what we expected. Then another transformation function we've not tried yet is the hash, maybe, given name. Hash function will take an argument which denotes the hash function. Then given name and given name hash. So the hash value, the computed hash value is this one, and the input given name is max. But we are not sure this value is correct or not. So let's compute it equal maybe this A1, A5, A1, A5, and ED8 means maybe the computed hash value is correct. And so, and another, maybe probably we should, we have covered all the, most of the defined transformation function. Then let's move to the next page of the demo. The next demo is a demo of predefined transformed claims and server metadata. Then now we'll edit predefined transformed claims like this, and probably an authorization server implementation that supports transformed claims will provide some user interface where you can edit the content of the predefined transformed claims. And then after this, we'll edit again claims JSON that will refer to the predefined claim. But when the predefined claims are referred to, two columns need to be added as a prefix. Then we'll repeat make authorization page, and this is will be included in the displayed page. And then as a last step, I'll type make conf. This will open the discovery document of the authorization server. It is well-known OpenID configuration, and let's check the server metadata related to transform claims. Okay, then let's start. So this is a management console of our product. Currently, this is the field we can input the predefined claim. So let's define age, name, our editor is not so. Really, this should work. Predefined age and age. Okay, then update. Okay. We defined predefined transformed claims name predefined age, and we are now saving the definition to the. Sorry for my machine is slow, so it takes some time. Anyway, let's edit this claims JSON. Now we do not need to include transformed claims because predefined transformed claims can be referred to without any transformed claims property. So the okay, now you can confirm that the predefined transformed claims is embedded in the ID token. The value is 65, as we expected. Then let's open the discovery document. And now this is the transformed claims predefined server metadata, which includes predefined transformed claims. And as we edited, the predefined age transformed claims can be found here. And this is the list at another metadata is transformed claims functions supported. And this is the list of supported transformation functions or any recall, get, GT, GTE, hash, LT, watch, none. And years ago, probably this is all the defined transformation functions in the current specification. So, do you want to know? No. Okay. So that's all. And thanks for watching.
Thanks a lot, Taka. That was very interesting, and I'm very happy to see the spec in action. Are there any questions?
Yeah, I have a question.
Go ahead.
Is this maybe a tag vector? For example, let's assume I am 17 years old and I want to use a streaming service, which asks my identity provider whether I am above 18 years. And the streaming service requests this by sending a customized transformed claims function. And in this function, there is in the function declared whether my birth date is greater or equal than 18 years ago. If I intercept this request and exchange this 18 by let's say 16, then my identity provider will ask me whether I want to tell the streaming service if I am above 16 years. Then I say okay, but the ID token will or the claim in the ID token will anyway be called above 18. Is that right?
Yes. Yes, that is a potential problem. This can also be a problem when, in general, you have any claims that you pay for, so the relying party pays for, then you also have the problem that if somebody adds a couple of claims, then a relying party might get data that it doesn't want to pay for. So what you need to do in these cases is that you need to have integrity protection for the authorization request. So ideally something like the pushed authorization requests, where the authorization request is sent server to server in the background, so that the end user in front of the computer cannot modify the request.
Okay. So the streaming service will sign this this request or remember the request, and after that the identity provider will sign what was the message which was received by the streaming service, and it will provide it in the response so that the streaming service can check whether it was modified or not.
That is not actually needed if you send the request in the, so the idea is that the streaming service would just send a direct request to the identity provider before anything else. And in that request in the background, so server to server, it defines the, among others, the claims parameter so that nobody can modify it.
Okay. Yeah, I understand.
Yeah, so that would be the idea.
Okay, thanks.
There's, okay. Any other questions? Dennis?
It's not a question, it's a comment. It seems to me that another approach would be able to simplify the task if you allow an end user to ask first all attribute types, and in some cases, values that he has, so that he is able to know in advance which one are known. So it doesn't need to have a complicated computation for every one of them. Well, if you have a surface mail address, an easy way to extract one partial element of the address, let us say the last one, which is the country of the residence may be interesting. So you point, let us say, to element 5 of the surface mail, and it's sufficient to say, I only want the country. And in addition to that, I believe that we should define an age range function, not simply higher than or older than 18 or younger than 18, but a range function that is, of course, a computed attribute computed from the birth date. And if you have all of them, this should be able to simplify what I have seen today. Would it be correct?
So I think the first one you proposed would essentially be the get function that we saw. And a range function, I guess that would make sense. Yeah, of course. So you can express that already today, but you would need to have, I think you would need 2 transform claims based on the birth date. But yeah, range would probably make sense. And the other one, I think that's covered by get.
Well, I'm not speaking anymore of transform. I say, for example, if I ask for an age range, I add 2 parameters. The first one is younger than, the other one is older than, if both exist. And this should be directly understandable so I can get the right information.
Yes. So all of, or many of these options have been discussed in the eKYC working group and elsewhere. And at the end of the day, they were very specific to one use case, say age verification. And at the same time, they didn't cover any of the other use cases. And also in the, what you have in the eKYC specification is that you have a lot of dates, for example, a date when a document was verified. So you might want to express things about that as well. So it's not always the age of the end user, but sometimes it's you want to say that this document has been verified in the last 5 years. So you need some kind of bit more generic syntax to express these things. And I hope that is what transformed claims gives you. And as I said, with the predefined transformed claims, you can boil it down so much that it ends up being a very simple implementation in the backend.
Well, I got the impression that you have a hammer and you want to address all cases with that hammer. I understand that for some cases, the hammer may be needed, but for the most current attributes you want to extract, the hammer should be not necessary.
I see it a bit different. I think of this as a toolbox, but in most cases, you will only need the hammer.
Dennis, if I may add, I work with Daniel on the working group, and we did have plenty of debates about some of the edge cases, but in the end, finding something that was of wide utility but still relatively simple was where we tried to end up. I hope that's what we have achieved, and with Taka's fantastic support, we've demonstrated it is at least possible to implement once. So you know, that's a start on the journey of proving this is a viable solution. If you're interested in helping us refine it further, you're very welcome to come and join the working group, of course.
How can one do that?
I'll send you a link. I'll actually pop it in chat.
Are there any other questions or comments? Mike, as one of the authors of OpenID Connect Core, I would be especially interested in your opinion, if you have one.
I was mainly going to ask for status from the working group on where we are on the standardization process for this and how many implementations we have.
Regarding implementations, I'm only aware of Taka's implementation so far, because we are in an early state with this. So I think, Mark, has it been adopted by the working group? I think so, yes.
Yeah, we've adopted the document, but we haven't made it to an implementer's draft yet, which I think is what you're getting at, isn't it, Mike?
Okay, well, at what point do you think the working group will want to do that? Do you have
we've started having a conversation in the working group about when to move towards an implementer's draft one, but we haven't come to a conclusion about that. There's not probably too much more work, but we did want to give it a little bit more time. There's a couple of issues and PRs that we need to go through. So probably not too far in the future, but not formally decided yet.
Okay, very good. That makes sense. Thank you.
Okay, then thanks a lot for coming to our session. And yeah, if there's any other feedback, let me know via the usual channels. Thank you very much.